Good morning. How's it going?
Good morning.
Morning.
And how
I'm
are
just
you?
looking at French recipes.
Did you
Feeling-
say French?
Feeling a little bit French today.
Okay, good to know. What are you going to make?
I have no clue. It all looks really hard.
Can you guys hear me? I had my weird mic issue again. Okay, good. Stupid. So I didn't even hear what you said you were going to make or if you hadn't decided. So that was depressing for me.
I think it's way too hard to make anything. I'm looking at it. I don't even have half the ingredients.
Maybe you could make French toast and then you'd feel better.
There we go.
Maybe that'll work. Good morning. All right, good morning, everyone. I hope everyone's doing well. Happy Thursday. Yay, happy Thursday. It's Thunderbird Thursday. I have some stuff to share. Maybe I shared it already. Hopefully there's something new in here. Let me get there. Okay, by the way, can you see my screen? Do you love that meme? Is that your favorite one ever? It's one of my favorites. Yeah, why isn't it called a permutation lock, right? I'm sure you wonder. Okay, because order matters, right? Thinking. I love that. Okay, Thunderbird Thursday. This first one we've gone over before because it is the basic needs, but just as a reminder, the food pickup is still going on, the We Care Wednesdays. Wednesday, November 4th is one of those days. And if you are in need or you know someone in need, please, please, please send them to that. Then there's some other links to some helpful resources for you of Psychology Today and so what is happiness, basic happiness, and then it talks about the science of happiness and how you can improve your happiness. And then the other one is 3 positive psychology practices for troubled times. So it talks about just things you can do. And we've talked about some of those things in here. I'm going to share my other screen since I don't have this linked in here and show you how we really are doing things that are helpful. So here we go. So right here, this is that second article, 3 positive psychology practices for our troubled times. So practice 1, 2, 3s of gratitude. Remember that day when we wrote down all the things we're grateful for? Yeah, so you can practice that and hopefully you're keeping that list somewhere. Write a self-compassion letter. Some of you are big writers, and so self-compassion means directing toward yourself the same supportive and nurturant stance that you might direct towards somebody you were trying to support. Have you ever noticed that sometimes you're way nicer to other people than you are to yourself? If something goes wrong for somebody else, you're the first one there to comfort them and go, oh, it's okay, it'll be okay, it's not that big of a deal, or you're such a great person in all these other ways. Why don't you do that for yourself, right? Like, we need to make sure we're taking care of ourselves just as much as we take care of other people. So don't forget about that. And some of you are really good writers. We're actually doing some little group meetings where we share poetry or share songs and things like that that are important to us. So that's a good idea, you know, to really get out all the critical thinking and then really focus on your self-care and how you could write something to yourself that would help you. So it wouldn't take very long, probably 10 or 15 minutes, okay? By the way, this article is fascinating. I don't know if you say it says, if you see it, it says many people believe that by engaging in self-criticism, they're helping themselves improve or accomplish their goals. So being hard on yourself will help you. And they say the research shows exactly the opposite. People are more effective when they're able to be kinder to themselves. Self-compassion might not only help you feel better, but it might help you also make constructive action. So that's really important. So I think some people think that, you know, tough love to themselves will make it better, and that's just not true. And then a walk. Here's a nice one. Taking a walk is probably one of the safest things you can do right now, right? As long as you're walking by yourself, away from other people, in a safe place. Right now, the weather's getting perfect. Take advantage of it, even if it's just 5 minutes. I don't know about you guys, but I am trapped in my house a lot, like from 8 in the morning until 2 in the afternoon. And I could just stay and keep working and working and working. But sometimes just that 5-minute walk changes your whole attitude, makes you feel better, and makes you feel rejuvenated to get back to work. Otherwise, I can sit in my office and I don't get a lot done. I'm pretty unproductive, even though I think I've been working this whole time. If I take a break, go on a walk, come back, I feel better, right? I know Maddie was starting a birthday jog. It could be your birthday jog, right? So that makes you feel better. And but it doesn't have to be huge physical activity. It can just be a nice little leisurely walk. I don't know where your mailbox is, but my mailbox is kind of far away. It can just be taking my silly dog who has trouble walking to the mailbox and back, right? That's a big event for us. And I do feel better when I come back. And by the way, just visiting my dogs makes me feel better because they're always like, I'm the most exciting thing on earth, right? Okay, so I'm going to share these slides with you, you know, after class. if you haven't noticed, all these slides are put up right after class, and then the links are all live in them. So it's in a PDF document. Okay. All right. So anything that anybody else wants to share for Thunderbird Thursday? You good? All right. So let's look at this. This is not your warm up. It is your warm up, but it should be, that was the same one from yesterday. I changed it a little. Thought I changed it a little. There we go. So I changed it a little bit. Try this one. 11 Olympic sprinters are eligible to compete in the 4x100 meter relay for the USA Olympic team. How many 4-person relay teams can be selected from among the 11 athletes? Okay, so try that one. And then when you're done, get it ready in
You
the
have
chat.
to share your screen.
Oh, pickles. Thank you. There you go. So 11 Olympic sprinters are eligible to compete in the 4x100 meter relay race for the USA Olympic team. How many 4-person relay teams can be selected from among the 11 athletes? All right, you guys got it ready? 3, 2, 1, go. Very nice. Okay, let's check out our answers. Hopefully you did better on this. Excellent. 7,920 4-person relay teams can be selected. I think after yesterday and then after some practice on more, hopefully you could figure that out. Any questions on that? I think you did great. So today we're going to continue with permutations. And sometimes they get a little bit tricky if you've been on your more practice homework and you've noticed that, oh, I don't really know what's happening on this one. By the way, remember how you guys told me that you had one that you had to put it in scientific notation? And you couldn't figure out how to do that?
There's a few.
Wasn't it asking for a fraction?
Yes, but when you do it on your calculator, it will give you scientific notation.
And you should be able to switch it to a fraction. If you have the TI-84, you can do it. Maddie and I were struggling with the TI-83. Bobby, are you able to change it? Like, do you remember any of those numbers, Maddie, we were putting in? It was like, one of them was 6 over, I'm trying to think of the fraction it was. Let me see if I still have it in my calculator.
It was either 20 or 21 or 19. There was a question.
Yeah, I'm trying to think
So
of the numbers to.
If I
Go
just
ahead, Bobby.
make a really small number, like 6 over 589,302, it's going to give
Yeah.
me an answer in scientific notation. There's no
Yeah.
way on my calculator, the TI-83, that I know of, and I would love to learn a way to get it back to a fraction.
Oh, I was hoping you were going to tell me, because on my TI-84, it works perfect.
So I have it up here. It's just the same process, right? Math, frac, enter, and
Right,
it
right.
just spits back out the scientific notation. So
Let me check the
what I usually
Desmos.
do is I'd go by hand. I'll like try to reduce this fraction manually.
You mean simplify, right?
Simplify the fraction. Yes.
Okay, and what's interesting on Desmos, it won't let you either. But on my TI, it totally works. So if you have an 84, it'll work. But if you have an 83, it won't. And so Maddie and I were working on some last night, and that's exactly what we did. We simplified the numerator and denominator just manually because we noticed that the top and the bottom were both even. So we divided the top and the bottom by 2, and then we just continued that until we had it simplified. So kind of a little annoying that the TI-83 won't do that, but and I'll keep investigating and see if there's a way to make that work. But otherwise, you can just simplify the fraction. Okay. Okay. So you didn't finish the PC6 practice problems because we just started them. So we will do those in just a second, but I want to do some example problems with some permutations. So I'm going to put this worksheet in the chat for you. And Bobby, remember that problem that we were having trouble on 19?
PC6, yeah.
So on 19 in PC6, Maddie and I were working on it last night, and the correct way worked on the second one on that version. So there must be different versions where it works or it doesn't work, which is even worse. So I did put an email into the programmer about that problem. So if you struggle with number 19 on PC6, send me a message so I know that it's your problem on number 19. First of all, I can give you credit for that, but also I can tell our programmers where their error is, because the error isn't happening every time. It's only happening sometimes, which is troubling, right? So we need to get that fixed. And then I can still give you credit for that problem. I don't want to remove it from the assignment because that screws all the assignments up. So I'll leave it in there, but I can give you credit for number 19 if you're having trouble. Okay. Ooh, 21 was the one, Maddie, that we're going to go over today. So, and then after today, I think everybody will be okay with 21. Okay. Yeah, Maddie did her tutoring assignment already with me. And Maddie, did we get all of PC6 done?
Yes, I think the last 4, what was it, 18, 19, 20, and 21 were the hardest ones. So I'm glad I came to the tutoring and got it done with, because it was a little hard.
Yeah, it was just Maddie and I hanging out doing math. It was super fun. Well, maybe not for her, but it was fun for me instead of just sitting here by myself, right? Because I was here anyway. Okay, so let's look at this first example. Here's the formula, okay? So the formula says, why do we want to use this complicated formula when it's actually easier to use the basic counting rule? Well, sometimes we don't use this formula very often, but it's nice to know that the formula is there, okay? So the formula for a permutation is this, where you have NPR. This is where you have without replacement and order matters. And so the formula says, take n factorial, which n is the number of things you're choosing from, and then you're dividing it by n minus r factorial. So let's just make sense of that formula. And by the way, you can use that calculator, that stats calculator, right? My calculator's freaking out right now, which is a little troubling. Okay, so you can use that stats calculator and find P. And remember how that problem we just did? The problem we just did with 11 sprinters. So we would do P and we would have 11 and we're choosing 4 runners. So we would do 11 factorial over 11 minus 4 factorial, which would be 11 factorial over 7 factorial. And you're like, wait a minute, I just did that problem really easily without this crazy formula. And I totally agree. We only need the formula in some very specific circumstances. If you put this in your calculator, you'll get the same answer we did with 7,920. If you want to know the math behind it, just so you know, this is how you could write it. We know 11 factorial is 11 times 10 times 9 times 8. And then instead of writing the rest, I'm just going to write times 7 factorial. And then in my denominator, I already had 7 factorial. So these are going to simplify. 7 factorial over 7 factorial are going to simplify to 1. And I'm just going to be left with this 11 times 10 times 9 times 8, which I already knew. Okay. So you don't have to do it with the formula. I'm just showing you the formula, and then we will use it every once in a while. Okay. So questions on just how the formula works. Does everybody understand how to push the buttons on their calculator to make it work? Yeah, okay. So on most calculators, you have to hit the 11 first, then you hit the math button. And then I just want to make sure I have the steps right. 11, math, and then you arrow over to the PRB menu, and then you select number 2. And then when you do that, it's going to make it look like this. It'll say 11 NPR, and then you put in the second number, 4. Okay, that's just in case you need that. Okay. So here's an example. How many ways can the letters in math be arranged to form a 4-letter code word? And it could be a little bit different, but so here's the trick. We've done this already. We can't replace it. We have 4 choices for the first letter. Then we have 3 choices for the second letter, 2 choices for the third letter, and only 1 choice for the last letter. So 4 times 3 times 2 times 1. You can do that on your calculators. If you do math, or sorry, if you do 4, math, number 2, and then this time you're doing 4 choose 4. You're doing 4 choose 4. And so that will still turn out to be 24. I don't care if you do it this way or if you do it this way. I want you to understand the problem. Does that make sense? Okay. So here's one that's very similar to one on your homework that you might have been stuck on, okay? So 4-letter words are formed using A, B, C, D, E, F, G. How many such words are possible under each of the following conditions? So if it says this part, no condition is imposed. So that would mean it doesn't matter the order, it doesn't matter if I repeat, it doesn't matter any of those things, okay? So how would I do that first problem? Any ideas how you would do part A? Some of you did this for homework, I know.
Wouldn't you, let's see, 1, 2, 3, 4, 5, 6, 7 times 6 times 5 times 4?
What if I said I could repeat them?
If you can't, also to be 7 times 7 times 7 times 7.
Very nice. 7 times 7 times 7 times 7, which is 7 to the 4th power, which on your calculator is 2401. Is that what you got? Okay. Now, that one you can't use your permutation formula for because order doesn't matter, right? I can put these in any order, and the permutation formula is for when order does matter. Okay. The second one, no letter can be repeated. That's the one Maddie was talking about already. So 7 times 6 times 5 times 4. And so on that one, you would get 840. These are the ones that get a little bit tricky, C, D, and E, where they say, okay, each word must begin with the letter A. So if you want to think about it like this, we have our 4 slots. This one has to be an A. Okay. So how many choices do we have for that first slot? Only one choice. So I'm gonna erase this and put a 1 underneath it, or 1 here. That's an A. Then I have all these other choices. Now here's the question: can I repeat the A? Does it tell me if I can repeat the A or not repeat the A? I can repeat it, right? Because it doesn't say. So I have 7 choices for this slot, 7 choices for this slot, 7 choices for this slot. That's the part that might be confusing for some people, because they think, oh, if A is the first letter, I've only used 6 for the rest of the slots. But it's not true, because it doesn't say we can't repeat them. So we would get 343 for this one. Now, the next question is very similar, but instead of A being the first letter, they're saying C has to be the last letter. What do you think the answer will be on that one?
Would it just be the same as the previous one?
That's exactly what it is. It's exactly the same, because it's going to be 7 times 7 times 7 times 1, which is still going to give you that 343. Okay, I want you to try that last one and see how you're doing. So first of all, let's make sure we understand it. The second letter must be a vowel. So the vowels are A, E, I, O, and U. So just so you know. So try that one and see what you get. And you can put the answer in the chat. Don't hit enter yet. Okay, do you guys have that one ready? Okay, let's get it ready in the chat. And 3, 2, 1, go. Look at that. Nice. Nice work. And you got the 686 because you did 7, 2, 7, 7. Because instead of only having 1 choice for the second letter, you actually had 2 choices because you had an A and an E. But since it didn't say we couldn't repeat them, we still have 7 choices for the other slots. Questions on that? All right. This is the part that Maddie and I were really looking at for problem number 21, I think it was, on the homework. Okay. So if you got stuck there, and it might have been 20 and 21, I can't remember, because I think, or maybe we just did the problem a couple times to make sure we understood how to do it. So sometimes we have a question that says, how many distinct ways or unique ways can we do it? And we might have things that are repeated. Do you see these repeated digits? So this might happen. And the problem that Maddie and I had it on was where there were 3 women and 3 men in a line in a grocery store, right? Have you seen that problem? You might have had a different number. It might have been 7 men and 7 women in line at the grocery store. And it says, what's the probability that the first person is male or female, whatever it says, and then that the genders alternate? Yeah, have you gotten to that question yet? If you haven't, make sure you're taking notes and you write down that this is for Maddie. I'm almost positive it was question 21. Do you think it was 21? Okay, so question 21 on more, you need this kind of formula, okay? This kind of idea. So let's make sense of this problem. It says, in how many ways can these digits, okay, be arranged? So if there are any 0 digits, it's okay if they're in any position. It says it doesn't care. But then, so we have almost a new formula here. So we still have how many items we're choosing from in the numerator, n factorial. But in the denominator, notice we divide by all the duplicated numbers, okay, or duplicated objects. So if we look at ours, we have, what do we have? We have just 1, 1, 1, 0, 1, 2, but we have 2 4s, and we have 2 8s, and that's it, right? Everything else is unique. So that changes our probability if we don't have unique numbers for each one, or like in the problem, if we had 3 females and 3 males, those are duplicated items, okay? So we're still choosing from, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. So, oh, I don't like that. 10 items, so we're going to do 10 factorial in the numerator, okay? In the denominator, we only have to put the duplicated items. So we have a 4 duplicated twice, and we have an 8 duplicated twice. So we're not going to write 4 factorial and 8 factorial. We're writing how many times it repeats, okay? So we're going to write 2 factorial and 2 factorial, because there's 2 4s and there's 2 8s. Okay, and you can plug all this in your calculator if you want, as long as you put parentheses around your denominator, if you're doing it in one step, or you could write it out and make sense of it. So this would be 10 times 9. I'm going to write it all out so we can make sense of it. 7, 6, 5, 4, 3, 2, 1. And then this would be 2 times 1 and times 2 times 1. So this 2 times 1 and this 2 times 1 can be gone. This 1 doesn't really matter, because if I divide by 1, nothing happens. And this 2 can be taken out of this 4 and become a 2. So I could just multiply 10 times 9 times 8 times 7 times 6 times 5 times 2 times 3, and I would get the answer. Or I could make this device do all my work, right? Does everybody know where their factorial button is? Yeah? Okay. So if you just plug it into your calculator, so on mine, I have to hit 10, and then I have to hit math and go over to that PRB menu to get my exclamation point. Very nice. Thank you, Bobby. And then I'm going to divide. The only thing you have to remember is put parentheses around your denominator. So 2 factorial times 2 factorial, and then I'm going to end my parentheses. And then I'm going to hit enter. So did you get 907,200? Okay, so the trick on the one on Canvas and on more is that number that you get from this is your denominator, because those are the possible outcomes. And in that question, it's asking for the probability of that happening. So your numerator almost always is going to be 1 out of that number. Okay, so this becomes your denominator and 1 is your numerator. That'll help you with number 21 on your homework. Any questions on that one? All right, let's look at number 4, example number 4. 6 cars are entered in a race. They all have an equal chance of winning, and there are no ties. Spectators are invited to complete a single prize ticket with their guesses for which cars will win. Here's the important part: first, second, and third place. As soon as it says anything about first, second, and third place, you know it's a permutation, because order matters. It definitely matters to a driver if they come in first or if they come in third, right? So this is definitely a permutation when you see that first, second, or third. The spectator who correctly guesses the first, second, and third place finishers will get a small prize. So the first question says, okay, how many ways can we complete this ticket? Like, how many ways could we do it? You can use your permutation formula, or you can just use our idea from yesterday, where we would have 3 slots because we have first prize, second prize, and third prize, right? I don't care which way you do it. Okay, I just want you to understand it. So if you're doing it with our slots, then remember there's 6 cars. So my first place finisher, there's 6 choices. But once one person has won first place, they can't win any of the other places. So this is going to decrease in each one. So we're going to get 5 in the second one and 4 in the third one. So there should be a total of 120 ways you could complete the ticket. Can you guys tell me what the NPR would be on this? Like, what would I write if I was going to do it with my permutation formula? What would I write for the N?
Would it be 6?
Yep. And what would I write on the other side for the R?
3?
Yep. So what's nice about this is now you have 2 ways to solve the same problem. That's really nice to be able to check your work. I really stick with this way almost all the time, right? Unless I can't. Okay. Like if I have duplicated items. So I usually do the slots, but then I'm like, ooh, I think that's a permutation. I'm going to check that on my calculator and see if it's right. And then I get the same answer and it makes me feel better. Like, oh, I got the right answer. Okay. Yeah. And I cheered just like Bobby. Did you just see Bobby cheer? It's true. It's true. Okay. So now it says, what's the probability that a spectator will win the small prize? Some of you might think that's kind of a tricky question, but we just figured out the possible outcomes, right? So that's going to be our denominator. And so the probability that a spectator wins is going to be 1 over 120, because one spectator is going to win out of 120. Is everybody all right with that? That might be where you were a little confused. Okay, now how about this last one? Says, suppose spectators are allowed to complete 9 different prize tickets. What's the probability that a spectator with 9 prize tickets will win the small prize? Any ideas how you would do that? So the probability that they win is 1 out of 120. But what if they're allowed to buy 9 tickets?
So I did 9 times 1 over 120.
And you got?
3 over 40 or 7.5%.
And we'd start with 9 over 120, right? And then it would simplify.
Oh, okay.
Right? It's the same. So exactly. So Kate said she multiplied. You could even think of it as, okay, here's the probability on my first ticket. Then I have the probability on my second ticket. Then I have the probability on my third ticket, and so on, all the way up till I have 9 of them, right? So that's where that 9 out of 120 came from. Or Kate just said, I took a shortcut and multiplied 9 times 1 over 20. 1 over 120, sorry. Forgot about that little 1. Yeah, it's an or, so we add them. Excellent. Okay, sorry, I know this is a little boring for you, but I think it's important to help you get through that homework and make sense of it, okay? Maybe it's just boring for me because I like to hear you talk instead of me talk, but that's all right. Okay. How many of you saw this problem on your homework? Kate's like, why didn't I wait till tonight to do my homework?
This one was so hard.
So
I agree.
it's actually, the only thing that made it hard was the wording, because the math's really not that hard. It's the wording of the problem that kind of boggles our mind. That's why I didn't make your homework due until tonight. So I'm so happy you guys worked on it. But if you're stuck like that, and you know that I'm going to cover the same material the next day, maybe send me a message or pause, because we're going to get through it in class. I don't usually leave you hung to dry, especially when there's no videos on this. Maddie and I were talking about that too, that a lot of these problems didn't have videos. And so I want to add some videos. I don't think every problem needs a video, but maybe a couple videos, especially on the problem like number 21, and maybe this type of problem. What do you think? You guys think the videos would help? Or I can just say, nope, no videos, you're good. Okay. The videos help. All right. Yeah, Bobby, thank you. That's exactly what it's like. Bobby, do you want to go over this one with them?
Yeah, sure.
Okay.
These ones are worded, and there's a lot more words than our example that we did early on about choosing a wardrobe, how many outfits could we make, but the idea is very similar. We're choosing a house to have these builders in this development complex build, and they present us with different options, different choices to make for the number of bedrooms. Okay, yeah, if I can write on it, that's perfect. Sometimes I can't, so I don't always try, but I'm gonna get my pad.
Yeah, I don't know.
Annotation.
Hopefully you can. If you can't, let me know.
You have to go up to your more options for screen sharing and enable annotation. It's from like the little drop down next to the green bar. But you're using your iPad to share, so I don't know if it looks a lot different.
Yeah, I can't find that option on there, but let me share it with my other screen. So then you can write on it and see if I get that option.
Okay, yeah, thank you. Yep, and there is the annotation option for me right
good.
now. So yeah, so we're choosing this like composition of our house in the same way we're kind of choosing the composition of our wardrobe, but instead of pants, shirts, shoes, and ties, we have bedrooms, bathrooms, floors, and types of yards. So we still have 4 slots, 4 of these blanks that I like to draw to visualize how many things I am choosing. And then for each of these, let's make this first option a bedroom, a bathroom, floor plan, or number of floors, sorry, and then yards. So these are my 4 details of the house that I'm choosing from. And how many different choices do I have for a number of bedrooms? Well, here they say that we could get a 2-bedroom, a 3-bedroom, or a 4-bedroom. So I have 3 choices to choose from for the bedrooms. How many choices do I have to choose from for the bathrooms? Well, I could choose 1 bathroom, 2 bathrooms, or 3 bathrooms. So again, I have 1, 2, 3 choices to choose from. How many floor plans or how many choices do I have to decide from when I'm asking these builders to build the floors? Yeah, Ulissa nailed it. There's 2. I could get a 1-story or a 2-story. If they gave me the option of a basement, that might be a 3-story house. So, but in this case, we only have a 1 floor or 2 floors. So we have 2 options. And the type of yard, how many options do we have for our grass or desert landscaping? And Ulissa nailed it again. There's 2 choices there. We can either choose grass or we can choose desert landscaping. We aren't choosing more than 1 option for any of these specific details about our house. So really, once we get to this point, we're just ready to multiply. 9 times 4, 3 times 3 is 9, 2 times 2 is 4, 36. 36 house configurations or houses. So there are 36 total house configurations. And then here it says, like, for us to ask, well, you would like to buy a house with 2 bedrooms, 3 bathrooms, 2 floors, and a grass or desert landscaping. So this is our denominator. This is, now we're asked about a probability. What is the probability? So I want to set up a fraction, and I know that initially my denominator, probability of success over total. We've just done all that work to find our denominator size of 36. So if we are choosing this particular house with a 2-bedroom, so we would like to buy a house with 2 bedrooms, 3 bathrooms, 2 floors, 2-story house. And then here we have a little bit of flexibility, desert or grass for our landscaping option. So we want one of the 3 options for the bedrooms. We want a very specific 2-bedroom house, 1 out of 3, but we've already found our total. So right now we're just kind of working on our numerator. There's 1 option for the bedrooms. There's 1 option that we would be happy with for our bathrooms. That's the 3-bathroom configuration. So we're only going to take 1 of those. 2 floors, again, very specific. Out of the 2 choices, we're only happy a success of the 1 2-floor, the 1 option that gives us 2 stories. And then the last piece of our house, which is like the grass or desert landscaping, what are we going to put there? What are we going to multiply there? Yeah, Jonathan, great. We have 2 choices that we'd be happy with. We'd be happy with either or. So 1 times 1 times 1 is 1, times 2 is 2. 2 over 36, and then we need to simplify this. 2 and 36 are both even. We can divide the top by 2 and divide the denominator by 2, and we would get 1 over 18. So this, I didn't use my space probably as nice as I should have.
No, you're fine. It looks good. So the key is to first figure out how many total possible outcomes there are, right? And then figure out what you're looking for, right? What your options are. And I scribbled this out because I thought it was a little confusing, what was happening over here. So, because it is true that would be, you know, these things, but that was just unclear. And I liked the way Bobby was explaining it better. You could even think of it like this. There's going to be 1 house that has 2 bedrooms, 3 baths, 2 floors, and 1 grass. Or there's going to be 1 house that it has 2 bedrooms, 3 baths, 2 floors, and 1 desert. So you could do 1 over 36 plus 1 over 36, which would give you 2 over 36, which still simplifies to 1 over 18. So it's just a different way to see the same idea.
Could you hear my whole explanation?
Yeah.
Like the whole time I was talking?
Yeah.
Okay, awesome. My headphones like stopped giving me noise because there was some silence, I guess. I was doing a lot of talking, but that's great. I'm very happy you could all hear that.
Welcome to my world, Bobby.
Yeah.
Yeah, of talking to the void. Yeah, that's why I make you have your cameras on.
There are a lot of ways to approach this problem, though. The fractions down here that Roxanne covered up are totally fine. You could think of these blanks as 4 individual fractions. So when I draw my bed, bath, floor, and yard over here, these could be their own fractions, and that's what you see scribbled out over here.
Right, and the reason I really scribbled it out is because they kind of left off the last part. Did you notice that? So they left off So the 1/3,
Oh.
that would be, it's 1 out of your 3 bedroom choices. The 1/3 is your 1 out of 3 bathroom choices. Your 1/2 is 1 out of 2 floor choices. What they really, I mean, to make sure we're understanding it, they should have another one right in here. That would be times, and you could say 2 out of 2, which is the same as multiplying by 1, right? So that's why that fraction wouldn't change. I just didn't want people to get confused because I like the slots better, you know, because it seems to make more sense. And that's how Maddie and I did it yesterday. We did it with the 4 slots. All right. Questions on this?
Yeah, you can
All
always
right.
message me in the chat too if that was a little fast, a little confusing. I'm always happy to explain it in a different way.
Yeah, no, I thought it was great, Bobby. And my dogs were going bananas. So I was like, oh, perfect. Bobby's going to present now because maybe they'll hear instead of hear my dogs the whole time. Okay. Here's the last example. Devin, Rocio, Myra, Gabriel, Gil, Elena, Juliana, I'm not sure. I didn't write that name, so I'm not sure who it was. Christina and Erica have all been invited to a dinner party. They arrive randomly and each person arrives at a different time. Find the probability that Erica arrives first and Rocio arrives last. So try that one. Think about that one. See if you get an answer. And we'll put it in the chat or we'll talk it through in just a sec. All right, do you guys have it? Let's see, 3, 2, 1, go. Am I missing your goes? Did you guys go? Okay, so there were several parts to this question, right? There were lots of parts to this question because first you had to figure out what are the total possibilities. Then you had to figure out what the possibilities are that Erica arrives first and Rocio arrives last. And then you had to make that a fraction. Yeah. So Caitlin, do you want to explain it to us, how you did it? You can share a whiteboard or just talk us through and I can write it for you, whatever you want.
Yeah, I'm just gonna talk through. So first I found the denominator, which was just the probability of all the outcomes, which was 8 factorial. And that was 40,320 possible outcomes, which will be the denominator. And then I wrote 8 lines, well, 8 spaces. And the probability of Erica being first, which is going to be the first one, is 1, because Erica is just one person. And then I went ahead and skipped to the last one, and Rocio will be last. So that will also be a 1. And then I went back to the second space. And if there's 8 people and 2 people are already arriving at set times, that makes 6 people. But because everyone's arriving at different times, it would be a permutation because order matters. So the next space would be a 5. The next space would be a 4, a 3, a 2, and then a 1. And then you multiply that. And that was 720. And then that's going to be the numerator. And then 40,320 will be the denominator, which reduces to 156.
That was amazing, Caitlin. Great job.
Thank you.
Excellent. So Caitlin had to do lots of different math there. So this part was the part some of you forget. And you knew it was 8 factorial because if you just had the 8 lines and anybody could be in any slot, you would go 8, 7, 6, 5, 4, 3, 2, 1. That's why it was 8 factorial. Okay. And then this was the specific circumstance that they were asking for, where Erica is first and Rocio is last. You could use it with permutations, right? You could use the formula. Okay. So, but does everybody see what Caitlin did? Nice. Okay, I'm going to show you on the next slide how you could do it using the formula if you want, right? So it's the probability of 6 choose 6, because that's the one where we only want Rocio last and Erica first. And the probability of 8 choose 8 is all of the possible outcomes. And then, so that's just a different way to do it. Okay. Good job. I'm impressed. Okay. So I don't even know what I just clicked on, but I'm very sad. Did I just open breakout rooms? Okay. There's a worksheet for you guys to work on. Look at your breakout rooms. It's your old attendance teams. Flashback. So remember your teams, like the web people or whatever they were, the Paw Patrol, the Fantastic Four, our turtle team. Remember those teams? Yeah, I put you back in those. So go visit them. Try a couple of these problems. Bobby and I will come visit you. If you really want to get to a more problem, you could do that as long as I see that you're working on things. Okay, that's the idea here. So Annie, you're the only one I didn't put in a room yet, so I just need to do that. Okay. All right, so you can work on this doc in those rooms. That'll give you more practice, or you can work on your more assignments. Okay, but if Bobby and I come to your room, we're going to make sure that every person in the room is working on one of those 2 things. Okay.
Cool.
Hello. So Annie, how are you feeling about this stuff?
I feel like I'm okay for this stuff, but I think I'm gonna take some tutoring for the other one.
For the OR probabilities, PC5?
Yeah, the new stuff we did.
Okay. And I'm going to put up your review too, so you guys can get it early.
Oh.
Hello, you're back. Okay, I know that you weren't in there for very long. Was it a flashback? Do you remember that?
It was, except we missed
was
Andrew.
great.
I don't know where he went.
I know Andrew wasn't here today.
Oh, sad day.
Yeah, so you guys will have to tell him, like, hello, where were you? Okay, I just put in the chat a key to that PC6. Okay, so don't look at it until you're done. Okay. Okay. I'm also going to put your exit ticket in the chat. And then I was just telling a couple people that I'm going to release your probability review. Okay. So you can now, it's a week before your quiz. We didn't cover 7 yet, PC7 yet, but some of you, I know you'll want to get a jump start on it, and you will start on the ones you can do. Okay. So there's the exit ticket. You guys did awesome. And I'll see you Monday. I can't believe it's Thursday already. Time
I know,
is
so
flying.
crazy.
Crazy. Do something nice this weekend. Okay. Oh yeah, don't forget you have a review on Monday. So I'll
Yep,
put the review out today.
I got it officially approved. So yep, fully count on having an hour review similar to the last one. It's going to be Monday the 2nd, 2 p.m. to 3 p.m. And I'll give you guys details on Monday about how I'll get you that link.
Perfect. Yay, Bobby.
My dog is sleep woofing right now. It's so distracting. She's like
I
growling and
love
running
that.
in her sleep.
I love that. That's the best.
Oh, okay. Well, bye, you guys.
Bye. Have a great weekend.
You too.
Quick question. Do you
Yeah.
have any more worksheets or problems for probability type permutations? Because I struggle with that.
Yeah, I can probably find some more problems on permutations. And the other thing is you can always do in your more after you do it, you can just keep doing it even in, you can say, I don't want to change my score, right? Like keep my perfect score and don't mess things up.
Let me see. I know how to do it after it closes,
Yeah,
but how do
I
you do
think
it?
you can do it. Like, I think if you choose do a similar question, it'll ask you a question.
Without changing my score?
There you go.
Okay.
And so you can do that on any of them, but I'll also look for another worksheet so I can give it to you.
You could go hard mode and say, yes, change my score. I know I got the points on the last one, but I'm going to get them again.
Bobby.
I'm kidding. I'm kidding. Just just practicing. That's the better option.
Okay. Thank you.
Yeah, it's too stressful to do it the other way.
Yeah, no, I agree. I'm like, I got it once. I just want to practice.
Right, like move on. Yeah.
Yeah.
Bye.
Bye, Kate. Ulissa, how are things? Oh, maybe you're doing the exit ticket. I'm sorry.
Yeah, I was doing the exit ticket.
Perfect.